my level 400 talk about link to everything. So this is actually the thing I go totally crazy about. I'm currently in the cloud programmability team at Microsoft, where I do a lot of things related to data access. One of the technologies I've been working on is reactive extensions, which is one of those technologies that fits quite neatly in the whole camp of LINQ, language integrated query. And more recently, I've had the opportunity to make my hobby sort of my day job, which is writing link providers, writing all sorts of utilities around that. And today I sort of wanted to give you a waypoint at where we are with some of the things that we're thinking of doing. I can't really tell about the bigger story and the bigger mission that our extended organization is on yet, but believe me that LINQ might actually start playing a pivotal role in some of the things that we're doing going forward. So let's actually take a look at LINQ really in depth, but before we go there, I wanted to give some historical perspective. This is literally the slide from PDC a couple of years ago, actually quite a while ago, presented by Anders when we introduced Project LINQ. And so when you look at this slide, the fact that you have multiple languages, you have multiple backends is kind of, I would say the wet dream of a compiler writer. You have lots of front ends, you have lots of backends, and you have some uniform, thing in the middle that is, common infrastructure between both sides. You can actually win prize money if you know what's behind the censored database on the slide. Now, if you take a look at where we were 5 years ago and put that sort of in contrast with the things that we have today, you will definitely see that there is little recent innovation in, for example, query operators. The set of query operators that we had in LINQ to objects was sort of inspired by things like Haskell, where we had, list comprehensions and a lot of functions, including filters and maps, and we sort of took that over and just added a couple of small things, such as, for example, a zip operator in .NET 4. But that set is sort of complete for the typical kind of things you do with LINQ. Now, when we did this thing called reactive extensions, we introduced a lot of new operators that are applicable to the domain of event processing systems, which have to do with things like time. Like, for example, if you want to time out or delay a sequence, well, you want to have some different set of operators there. So the little recent innovation there is applicable to the LINQ to objects case, but beyond that, we see things sort of moving. Further on, well, since we're working in the cloud programmability team, it's one of my commitments to have at least one cloud picture in the slide. So here it is, and so I'm meeting my commitments now, which is good. But really, where's the cloud in this picture? That's also a question, like which kind of data sources do you want to go to with regards to LINQ to everything? So that's an open-ended question, and I hope that you get inspired by some of the ideas I will show you today here during my talk, where you might sort of see where we're thinking to go next. So, given that, let's actually fasten the seatbelts and sort of dive into some of the core fundamental principles of LINQ. And I want to start with a little bit of theory, and then it gets more practical towards the end. So, really what we're sitting on with LINQ is something very powerful called monads from functional programming. And I sort of want to drill down this idea of monads into your heads to the maximum extent possible, and sort of prove to you that this is really the case, that we're built on top of this fundamental principle. So what's a monad? You can read the whole thing, but I will just highlight a couple of things. First of all, a monad is constructed by two operations called bind and return and a type constructor M. I will actually show you that you already know those three ingredients today for LINQ to objects and for some other things. And then I will show you that you can do much more than just query operations using this ingredient. So the fact is, if the language implements that, we can do everything that people in the functional community have written for the last 30 years on monadic computation. So that's a pretty appealing thing. So secondly, what this thing does is basically the following. It chains some actions together to build a pipeline, okay, makes sense, in which each action is decorated with some additional processing rules. Now, the word pipeline here is kind of striking, that this article talks about a pipeline in terms of some mathematical concept called a monad. Well, a data processing pipeline is really a pipeline. You can even do something like in PowerShell, where you literally pipe, a sequence of objects into a where and into a select. Like, that's a pipeline. If that isn't a pipeline, I don't know. But this thing doesn't really have to do anything with LINQ. LINQ is a specific implementation of this. And finally, the composition here is also pointed out. It actually composes monadic functions to define a data processing pipeline. Again, this article that doesn't have any citations of LINQ talks about LINQ, but in a very abstract sense. So this sort of proves the point that this is a much more generic sort of mechanism available. So let's actually tie this thing back to LINQ to objects and sort of see where we are. So first of all, the first thing you need for a monad is something called a type constructor M. Now, type constructors is something, I won't talk too much about that, but some languages have more advanced type systems, even though the trend today is to have no type systems. I'm a firm believer in type systems, so if you look in Haskell, you will find the construct of type constructors. Really, the closest thing we have in .NET are generics and families of generic types. So the type constructor we're talking about for LINQ is IEnumerable of t and IQueryable of t. Later we'll see there are many more, like IObservable of t and ICobservable of t, which I will talk about in a second. The second ingredient we need is something called return. A return function that basically takes an object of type t and sort of injects it into this world on which we can do LINQ. It's basically a way to enter the ship, the steamship, and then do things there. How do you do that? Well, one way to do it for LINQ to objects is basically by just wrapping the single element in an array. Because once you do that, you have all those query operators available on top of that sequence. So you need to have a way to sort of enter the world of LINQ. So that's actually the monadic return operation, as it's actually called. Another example that I could give is clock arithmetic. It's not the ideal sample, but still. It's the same principle that, if you give me any number, any natural number, I can project it onto the clock. If you say, it's currently 38 o'clock, I can say, well, 38 modulo 12 gives me actually 36 plus 2, so it's 2 o'clock. Like you can basically, project something onto the clock, which is a confined world in which certain rules, certain data processing rules actually hold. Now, once you're on the clock, you might want to say, and now add to that number that you have there another 50 hours. Well, then it becomes 52 o'clock, but the data processing rules of the clock arithmetic will always do modulo 12. So the idea is that the monad of the clock would be the one that guards things from falling off, the range from 0 to 12. This is the same thing with LINQ. You first go into the world of enumerable. It's like, enumerable of t is the same like clock of t in this analogy. And then you need to have a way to sort of stay on board. You don't want to fall off a cliff. As soon as you do some query operator, you still want to be IEnumerable of t. And that's what's happening over there. The most essential operator to basically do composition in this world of monads is called bind. And it happens that we have exactly this thing sitting around in LINQ. It's called select many. And what select many does is as follows. We are on the ship of IEnumerable of t. And now this thing basically promises me heaven on earth, because I can transform an IEnumerable of t into an IEnumerable of r, which is of a different type. And I get some kind of safety feature here, where I have a function that takes in a t out of that original sequence, like it's no longer in the sequence, it's grabbed out somewhere, and I can project it onto multiple values. And with this thing, you can do a lot of things. You can implement where and select, all those operators you can implement in terms of this one, which is left as an exercise for tonight. You can always send me, and I will actually do the corrections, but it's pretty simple. So you can do that, and actually I have a project called minLINQ. If you go to codeplex.com/linksqo, I have a project called minLINQ that implements 90% of the query operators based on 3 essential ones. So that's a pretty interesting intellectual exercise. So this is a very interesting thing. Now, how does this relate back to LINQ being more powerful than it seems to be? So here's another example of a monad from literature called the maybe monad. And so the thing I want to do here is really abuse LINQ. That's one of the things I really like to do something what it wasn't designed for. So this is an often heard question to the C# team, like, oh guys, you have this double question mark null coalescing operator, and you have a lot of ways to deal with nullable types, but you don't have something that propagates null values. Please add that to the language. That's like a top feature request, and we haven't done that so far, maybe in the future, but people want this thing, the question dot operator. So what would it do? The question dot operator would say, if name is null, I'm not going to even try to call the toUpper function. I'm just going to return null straight away. Right? And if name is not null, I'm going to call the toUpper function. So this guards you against null reference exceptions. Of course, debugging becomes kind of painful if you chain like 20 of those null propagating dots and then the thing returns null and then you have to start wondering where did it become null and where did it get propagated. So that's a reason not to do the feature, I would say. But still, people want that. So a good exercise is to go to the C# team and ask, guys, if people ask for this and you would say, we commit to implement that, and we are not, but say, if you would do it, you ask a compiler guy, how would you actually implement that? They would say, well, the way to do that would be first we do a null check, which is really a branch false instruction. We jump to another location, and if it's not null, we call the toUpper function using virtual call. Like, they will start talking IL to you, like gibberish IL. I say no, you can actually implement this C# 14.0 feature in terms of a C# 3.0 feature called LINQ. I would actually suggest them to implement this feature in the language spec as this. I would say, rewrite the question dot operator using syntactic, transformation into this thing. From underbar in name, where underbar is a compiler-generated name, could be anything. From S in underbar to upper select S. Like, at that point, people stare at you and say, like, you're crazy. Now, what's going on here is that, this syntax, if you look at the C# 3.0 spec, this syntax gets turned into select many. It's a select many call, as we saw on the previous slide, and this is literally the translation you can find there. It's something like, copy this underbar here, over there, copy this piece of code here, the underbar toUpper over there, copy this S over there, copy that S over there. That's basically what the language spec says, how you transform those things. Now, what I say, using this library function, which is not IL functionality, but using a library function, we can now implement null propagation. Because now we get a method call that passes in the name as a parameter, because this is an extension method. If the name is null, we are not going to call that lambda expression, otherwise we will. So now I've implemented this language feature very cheaply with regards to the compiler logic, just transforming it into a LINQ expression, and the LINQ functionality can actually take care of that. So let's actually show that, because it looks totally crazy, but actually it is. So here it is. This is the hypothetical compiled code for this particular thing, which is also on the slide. Name question dot toUpper. Assume that you would translate that thing into this LINQ expression. What can we do with that? Now say that name is a default of string, which is a null value of type string. What will actually happen here? Let me actually step through this. Let's do F10. F10, the hypothetically compiled code comes along now. Name is null, as you can see. Let's do F11 to step into some piece of code. Well, what happened here? This is kind of crazy. I'm in a select many call for something of type T with a func of T, C and a func of T, C, R, whatever. This is really what the language compiled this LINQ expression into. It basically said name dot select many of, underbar goes to underbar toUpper and so on and so on. And it just happens there is an extension method available on type T that the compiler is choosing here. And that's simply because I put an extension method on generic type T. And that means it's an extension method actually on system.object, which is something you might not want to do, but still, I don't care about that part. So now we're in here in the library function. If I do F10 here, we'll see that the value is null. And if the value is null, I'm not going to attempt to call the selector function, which will do toUpper, because it will bail out on a null reference exception. Instead, I'm just returning default of R. I'm propagating the null value through. And so if I do this, we actually end up with the result being null. That looks pretty nice. So null propagation worked. Let's now see that actually real value propagation works too. Say that I pass in Bart here, and I do, F10 again to start this program, F10, F10, F11. I'm in the select many call. Now the value that comes in through the extension method is Bart. And now, of course, it's not null. I will call into my selector function. Where's the selector function? The selector function actually, if I do F11, oops, that lives over there. So you really see that the compiler just steered apart this little piece of LINQ code into little lambda expressions, and you can even step through those little predicates. If you simply do F11, you will end up inside your LINQ expression. And the underbar here happens to be Bart. We're now returning something as simple as, an uppercase Bart. I do F10, F10, and ultimately we end up with the result being Bart in uppercase. So, success. I used LINQ to null propagate thingies. And that's something that monads can do. Monads can actually, in this case, sort of weave the aspect of null checking into some code that looks the same on the surface. So every monad is about a certain aspect. If you actually look at the link to objects monad, link to objects is all about hiding for each loops. Like the select many of link to objects says, give me an enumerable of products and a function to project a product on its suppliers, then I can for each over all the products, for each over all the suppliers for all the products, and yield return all of them to you. That whole iteration logic is hidden behind the monad, behind the select many calls. So that's the basic idea of monadic bind or monadic select many. So that's sort of, to go totally crazy, to show you that LINQ can do much more. You can overload the syntax for anything you see fit. So now let's actually go to a separate topic. Actually, this talk is not very consistent. It contains lots of random thoughts that sort of all tie back to LINQ. So next thing I want to talk about is, and actually that talk design is actually by design, the fact that it's lots of random IDs. Here's a real question for you. Do we need iQueryable of T? Everyone knows iQueryable of T. It's the interface that LINQ to SQL, LINQ to entities, LINQ to SharePoint, all of those guys use to take, the expression, your query expression, and turn it into some ugly language, like T-SQL or, Camel or whatever. Now, the question is, do we need iQueryable of T really? Let's actually see what's so bad about it in certain cases. Say that you have a source of product. Think about table of product if you like LINQ to SQL or something else. And this thing implements iQueryable of T. What happens is that this particular query expression that you see on the slide just compiles fine. You can do a where, and you can do a group by, and then you can do a distinct, and then you can do an order by, you can do everything, just party. And that's because of monadic composition. You stay on the ship of iQueryable, you can do all of the query operators, and you're back in iQueryable. So you can just write millions of lines of code on the same data source, and it's all fine. So the whole thing compiles. However, a majority of query providers say at runtime you press F5 and you're so happy, my query is compiling, it will execute, it will be the greatest thing on earth, and then you get, oops, not supported exception. Does this really need to be a runtime check? Can't we move that check to compile time? And the answer is yes. Ever since C# 3.0, we can do that. And let's actually explain how to do that. So let's take a look. Here we have a query expression. Standard query expression using where and group by, as on the previous slide. This really translates into, by means of syntactic sugar, but it's very sweet sugar, it turns into a set of method calls. This is the only thing that's in the language specification about LINQ. It says this strange-looking syntax using from, where, select, order by, group by, and I forgot some other keyword, I guess, all those things actually translate into method calls. Okay, so we have a method call with lambda expressions coming in. Nothing in the spec says that those methods need to be found as extension methods. They can be anywhere. So let's take a look. In case the where method is an instance method on source, we can even control the return type. We can control everything because it's our method. So say that source of T implements a where method that returns a filtered of T, and say that filtered of T returns actually has a select method that returns a projected of T, then this query doesn't compile. And the reason is because the filtered of T, which is the result of calling the where method, doesn't have a group by method. If filtered of T would have a group by method, this query would just compile. You even get red squigglies in the IntelliSense to say, I couldn't find the group by method. What's going on here? Now, if you are iQueryable, of course you get all those methods because there are extension methods on iQueryable of T. But if you do it all with instance methods, it just works fine. Now, the thing is, if you have a rich API like SQL, you likely want to go for iQueryable because what you're building here at the bottom is kind of a state machine of types, where you say, oh, the user did a where, and then I have a filtered of T. And on a filtered of T, you can do a select. But maybe you can't do a second select after the first select, but you can do select over there. So you're building like a whole state machine of like what the user has already done and what the user can still do. If your API, like T-SQL, is very compositional and expressive, where you can nest all those things, you don't want to blow up your assembly with thousands of different types to accommodate for all the possible query expressions that people write. However, if you write something very silly and stupid, like link to Amazon or link to Facebook, that just has a where and a select and an order by, this might be a much better deal because you get compile time checking if the user tries to do take 5, and take 5 is not supported by the API. So I would say this is meaningful, and it just so happens that the first link provider we did was a very expressive one, like link to SQL, so iQueryable of T was the natural choice over there. Unfortunately, everyone said, well, iQueryable of T is the only way to build a link provider. Not so much. You can just do everything yourself using instance methods, and the C# spec has always said that. You know, we never pointed it out explicitly that you could do that. So let's take it one step further and go totally crazy. Link to Twitter, even more stupid. It can only do wheres, nothing else. So can we do something to guide the user to writing a link to Twitter query, only generating valid queries at compile time? So let's take a look. From tweet and Twitter, where tweet dot, okay, this looks all pretty good. We can do tweet.about, tweet from, tweet location. Let's say I do tweet.from. This is, by the way, Visual Studio PowerPoint edition. It's a pretty nice feature. So I'm doing tweet.from equals Bart. Now, let's try to do another where query. Let's try to add another filter based on, oops, about or location. Huh, where's the from thing gone? You can totally do that using C# 3.0. Everything in the spec permits you to do this. You don't need to change the compiler. You don't need to change the IntelliSense. It just works. I will explain to you in just a second how it works. Now, it feels like a little bit of Copperfield demo over here now. I'm not going to take somebody from the audience and sort of use a saw to X them in two, but it looks like a little bit of magic here. It's not that bad. So let's do tweet.about equals link, and then we could do another where dot, and then the tweet would only say location, and then I would try another where, and it would say it doesn't compile anymore. So how does it work? Here's the recipe. Recipe: use method overloads, build a state machine of types, and do a lot of operator overloading. That's the secret sauce. So let's take a look at how it works. Let's start with the type of Twitter. The type of Twitter will be a Twitter. Not much of a surprise. And Twitter has an instance method with called where that takes in a func, taking in a tweet about from log and a filter from. So let's actually walk through that. The type of Twitter is Twitter. The type of tweet will actually be the thing that the where method takes in. If you do something from x in some source where x something, the type of x is determined by the input parameter to the filter predicate of the where. Now in this case I say to the where method, actually as you can see where methods in LINQ do not even need to return a boolean, which I will use very handy in this case. This func actually takes in a tweet about from log. What's a tweet about from log? That's what I call a has a type. It's a type that has properties that are encoded in the type name. So it's a type, as you can see on the top of the slide, that has 3 properties, actually 3 public fields in this case, because properties don't fit in Visual Studio PowerPoint edition. It's called from string, about string, and log string. They're not even system.string. I just cooked up my own string class. Why is that? Because now if the user does something like where tweet.from dot, he doesn't see substring and to upper and to lower, all that stuff that's not supported by Twitter. I just show him all the types or all the operations that are supported on a Twitter string, a from string, a location string, and whatever. So I'm totally going bananas here, but now what I can do is tweet.from, right? Oops, let's actually go back. I can do tweet.from, which is of type from string. From string contains an operator overload, that allows me to compare a from string to a system.string, which is what the compiler happily chooses for where tweet.from equals Bart. It will actually call into that thing. Now, what's the result type of that operator, which by the way needs to be static in reality, but again I'm abbreviating some syntax here. That thing returns a filter from. So the compiler says, ha, that's nice, because I found a where overload that takes in a tweet about from log and returns a filter from. That's exactly what the user wrote. It completely type checks. Beautiful. Move on. That's what the compiler says. Moving on means, what's the return type of where? The return type of where is a Twitter by from. Look at the little trick here. Now I have a type that knows, as part of its value, of the name of the type, that the user already wrote the predicate on from. It's encoded in the type. So now I return a Twitter by from, which is the type of the first 2 lines of the LINQ query. And now, of course, on the Twitter by from, I have a where method. And the where method doesn't take in a tweet about from log. It takes in a tweet about log, which no longer has the from part in it. Which means if the user does a dot on that thing, he doesn't see location. Or he doesn't see from, because he already did from. So what's really going on here is that this LINQ query, the type of tweet, is different here than it is over there than it is over there. LINQ totally permits that. That thing doesn't need to have the same type in the entire query expression. Maybe it's abusing LINQ, not really, I like it. You know, that's the end of it. So this thing returns Twitter by about from. So this whole thing has of type Twitter about from. And then, you know, if I would do another where method, as you can see over here, the where method would actually now take in something that doesn't expose the other stuff anymore. So that's actually what's going on. Let's take a look at a little demo on how this actually works in practice. Because, you know, I can promise you in Visual Studio or in PowerPoint that this all works, but I need to show you that it's really the case. So let's take a look. From movie in IMDb. It's a similar silly API that only supports a where. Okay? I could do the same with Twitter or anything that just supports a couple of wheres. From movie in IMDb, let's try to write a query where movie.title equals Titanic. It's the same as on the next line, by the way, but I'm just reconstructing the query here to show you the IntelliSense. Where movie dot, oh, there's no title anymore. The only thing I can do is a year filter. That's nice, let's try to do that. Let's do another where, movie dot, no IntelliSense anymore. That means there is nothing to filter on anymore. The compiler didn't find the where method after the first 2 where methods, because, you know, the type encodes all of that stuff. So I could try to do that. I could say, you know, where movie.bar equals foo, and let's do foo in strings like this. It actually says over here, you know, could not find an implementation of the query pattern on something called filtered by year and title. I didn't find a where method. So it basically tells you at compile time that I can't do another where. It's a little unfortunate we don't have the squiggly sitting over here, but you know. And ultimately, you know, if I write this query, I can do a for each over that, and it just works fine. Now, you might wonder there's something else happening here, but let's first take a look at IMDb. IMDb is an object that has an instance method called where that takes in a movie query title year, which means it's a movie that has a query. It's a movie query that has a title and year property. So if I take a look here, it has a title and a year property, which are of some specific type. I just generated or created a type here called movie title. Movie title is something that only has instance methods equals and contains and an, you know, operator overload for equal and not equal. The not equal one actually is not supported, but I need to have a not equal one if I implement an equal one for C#. So in that case, I still resort to an exception. You know, that's kind of, you know, something that falls out of it. And if I have an equal, I need to have a get hash code and all of those kind of things as well, but that's not really interesting. So that's why a movie title is actually not a system.string, because now I can constrain what the user can write. So this thing returns a year filter if the user filters by year, and then I return a filtered by year. If the user actually writes a query that filters by title, which will return a title filter using operator overloading, we get back an object of type filtered by title. If we look at filtered by title, it only has a where method that allows me to query on the year, not longer the title, and that thing returns a year filter. At that point, what we get back is a filtered by both the year and the title. A filtered by year and title doesn't have a where method anymore, hence the compiler bails out on me saying there's no where method. So it just walks through, you know, just method resolution from left to the right. So that's what's going on. Now, one more question is, what did Bart do to make this thing for reachable? Import system.link, and yet if I do result dot, there's no order by and where and group by, and all the link to objects operators are not over there. How does this work? How can I do a for each if it's not an IEnumerable? The answer is, ever since C# 1.0, for each said, I do not need an IEnumerable to be enumerable. I just need something that has a getEnumerator method, and if the thing that's returned from getEnumerator has a moveNext method and a current property, I'm happy to bind against it. The compiler doesn't care about IEnumerable of t. It knows about it to optimize certain things, but it doesn't, in the spec, it doesn't say that you need to have IEnumerable of t. So the only thing I implement here on the result of this IMDb query, and I can actually, this is also a pretty cool feature, I can press F12 or go to definition on var. And var, basically, if you do go to definition on var, it simply brings you to the definition of the type. So in this case, it goes to filtered by year and title, which implements the interface called movie enumerable. And movie enumerable is not an IEnumerable of t. Because if it would be, you would see all the link to objects extension methods coming into place, which I cannot support. So I basically say, like, this thing is just something that returns a get enumerator, and the get enumerator basically returns an IEnumerator of movie, in which, of course, I do, all the ugly logic to go to a web client, JSON serialize, blah, blah, blah. Right? That's trivial stuff with just some yield returns somewhere. Yeah, yield return movie. So let's try to execute this, assuming that that service is online. Well, Titanic 9097 had 7.4 score in IMDb. So my query works, and it's totally checked at compile time, which is a pretty cool thing. By the way, if I do movie.title dot, as you can see, the only thing I get here is contains, because it's not a system.string. So everything is totally constrained here to what the server supports. So that works pretty good, actually, for those APIs that do not support rich queries. So far for do we need iQueryable of t. Next little chapter. All the chapters have a different view on LINQ. So we already demystified iQueryable of t. Let's now take a look at the fact that LINQ queries can also be written over other domains. You do not have to do LINQ over collections or enumerable sequences. You can do LINQ over anything, as I've shown with the null propagation case. So let's try to do LINQ over event sources. For those of you who were in my previous talk, you've already seen the slide. So you can take just a little nap for now. The idea is that Rx, the reactive extensions, it's something I've been working on for the last year and a half or so, which is available on MSD and Data Developer Center. And actually, today we're releasing the next version, a 1.0 version over there. So you can actually find a recent update pretty soon, by the end of the day or by tomorrow. The idea of Rx is actually to build those queries over something called observable sequences, which represent a source of events. For example, the Nasdaq Stock Exchange, typical sample I always give, would be an iObservable of stock tickers or stock quotes. So that's basically something, if you subscribe to it, it will start sending information to you, saying like something has changed, that kind of stuff. So that's the idea of Rx. It's about querying event sequences. The way we want to do that is by rich composition, and I've already shown composition from a different angle, the fact that when you use LINQ, you can basically dot into operators, and what you get back is something of the original type. Like if you do an observable and you do a where on that, you're still observable. And then you can do a select and you're still observable. So you can compose infinitely together. So that's a pretty nice thing. And third, the way we want to do that, as obvious, is actually using observable sequences and using LINQ. So what's an observable sequence? Let's actually explain that. The basic idea is that there are two ways of getting to your data. One way of actually acquiring data into your application is by enumerating over some data source. That's pool-based data access. You're basically pulling data out of the data source. That also means you can get stuck. You can get blocked while the database server is taking a nap, and you say move next. Well, it doesn't come back, so your application is stuck waiting for the result to come back. In the other world, the reactive world, the only thing you say is, dear observable sequence, I'm interested in getting notifications whenever something changes. And then that thing will start, sending updates to you. It will send data to you, and you have to react to the data being basically slammed into your stomach. So the data just travels to your application. You have to react to the data coming in. So the way this works is by means of an interface called iObservable of t. Could actually tell you that this is the mathematical dual to IEnumerable of t, which is pretty nice because everything we know from IEnumerable we can take over in iObservable. I won't go there, but essentially this interface looks a lot like IEnumerable put upside down. So iObservable has a subscribe method that takes in an observer, which is basically the callback mechanism. You give your data source, an event source, a way to call you back. So that's the thing you do there. What you get back from the subscribe call is an iDisposable. That's when you dispose that it unsubscribes. The reason we return an iDisposable and don't have a subscribe and unsubscribe method is to help with composition. If we actually would have a subscribe and unsubscribe method, we would have to keep a lot of state to sort of remember which subscription gave rise to all the other things we're doing in the system. And then, you come back with unsubscribe with the same observer, and we need to match everything up and then start disposing things. We just hand out some ticket behind which we have all the logic to basically clean up your event processing pipeline. Both those interfaces actually exist in the .NET 4 BCL in the system namespace, so you can actually start implementing them and use them. So I will show this in a demo in just a moment, but what this has given us is a landscape for sequence-based link, operations over sequences, that has grown significantly. So let me actually show you the entire landscape. First of all, the question is, what's the data acquisition mode? How do you get to the data in your application? There are only two ways. Either you pull the data in or the data gets pushed in. There's a third way, that's basically sending the data on a CD-ROM to the user. We don't consider that modern, so that's not in there anymore. So pull or push, those are the two ways to do it. Two interfaces, enumerable and observable. The left one you could say that's linked to objects. iObservable, that's linked to events. That's the way you should think about it. So we have those are both in-memory implementations, and we have conversions in both ways. You can take an enumerable, make it observable, which means you're no longer blocked when the enumerable is taking a long time to go to the next element. You can take an observable and turn it into an enumerable. So that's pretty neat stuff. The reason you might want to take an enumerable into an observable, by the way, is for testability purposes. You might say, well, I have some huge business logic based on text changed events, which is an iObservable of string. Whenever the user types something, you get the next value. Now, how do I test the UI? You could say, well, I'm going to mock the event. Ooh, I grew a lot of mocking things and, sort of putting a mole underneath, the system and sort of start eating events and do other things. I basically say, no, just swap out the iObservable of string with an enumerable of test inputs and then do toObservable on that. And then just give that to your logic, and the thing just tests based on the offline data that you basically give it. Nobody needs to jam on the keyboard for that thing actually to happen. So the two other axes, first of all, is the where axis, is where things execute. I will talk a little bit about that in just a second. That's based on a notion called iScheduler. The reason we need that is if you do event-based stuff and time-based operations, like please delay events with an hour, you need to have something that keeps a clock without blocking you. So you need to introduce concurrency to be able to do those kind of time-based operations. Now, the other axis that we have is the how axis. The how axis says, how does the query execute? And we already had two things in there with classic LINQ. We had a way to execute things in memory using a fixed representation of code, which is MSIL, but we also have a way to actually express queries over other data source, like, for example, a relational database engine, where the whole LINQ query gets turned into an expression tree that can be turned at runtime into some other language, like, for example, T-SQL, Camel, what have you. And that's called iQueryable of T. Now, you take this picture to any mathematician and basically ask, like, what do you think about my picture? And they laugh at you because they say something is missing. This thing is not super symmetric. You have to have something in the top right quadrant because otherwise it doesn't make sense to me. So what we did is, well, we put something in the top right quadrant. You can write queries over event streams that are based on expression trees, which means that the whole logic of the expression of the whole query can actually be remoted into some other engine that processes the data. And that's exactly what you want to do in the NASDAQ case, right? If you do something like, from stock quote in NASDAQ, where the stock quote.symbol equals MSFT, select the stock quote.price. Well, in that case, you don't want to get all the stock quotes streamed to your machine and then apply a where filter just to filter out that one company you're interested in. Now you want to take the where query, take it up as an expression tree, and send it to NASDAQ so that they can do the filtering before sending the results to you. So it totally makes sense to have this other interface, which we call iObservable. Don't laugh. Okay, so what's iObservable? iObservable is the dual of iQueryable. It's very similar to the iQueryable interface. The name is basically iObservable but spelled with a Q, and the idea is that there's no difference between the two. You never need to see the interface even. It's just some runtime plumbing to capture your query expression as an expression tree. It's something that only query implementers need to know about. For users of LINQ to SQL and LINQ to objects, the two things look exactly the same. We want to have the same thing with reactive extensions over in-memory events and out-of-process events. So this is the interface. A couple of things here. First of all, we don't have a non-generic equivalent because in Rx everything is generic. So it doesn't make sense to start talking here about the non-generic equivalent of this interface. So that's not important. Now the second thing is iObservable provider, which is the dual to iQuery provider, which is basically a factory interface to create expression trees. That thing doesn't have 4 methods, it only has 1. If you look at iQuery provider, you see that there are 4 methods. Let me explain why we don't have certain methods. First of all, we don't have the execute method. Too quick there. We don't have the execute method. Why is that? Well, in LINQ to SQL, you have an execute method. Where is the execute method used? For example, if you have something like from product in Northwind, do something, and then you say .sum of all the prices. So you're basically summing all the prices of the things in the Northwind database. The thing that gets returned from that query will be a sum, which might be of type decimal. Now, there's already an important thing there. If you do a query that does .sum, it becomes a blocking operation. You basically leave the world of IEnumerable of t, and you go into a simple decimal. It's even not deferred execution anymore. You have your query, you do .sum on it, and it's too late, it's going. As soon as you call the sum method, it starts executing somewhere else. And you can't cancel it, and you can't time it out, you can't do anything with it. It's going, it's synchronous. In the observable world of events, we do not want that. So we say we don't have a blocking execute method. All of our aggregation operators in Rx do not return a naked value type, they return an iObservable of the type. So for example, if you have an observable sequence of prices, and you do .average on that, you don't get a decimal back, you get back an iObservable of decimal that contains a single value containing the aggregate value. Why do we do that? Because now you can subscribe to that thing, and you say, it's already taken 1 hour to sort of compute this thing, let me just dispose of that thing. Because now it's asynchronous, you can stop it, you can basically start the operation, you can cancel it out. You can still start composing things, because it's still an iObservable, you can still do things like .timeout, .delay, .select, you can continue doing query expressions on those aggregate values as well. So an execute method doesn't make sense, because it would have to be blocking. The only execute method that we could envision would be one that returns a task of t, which is an asynchronous computation of a single value. But then we need query operators on task of t for all the things that Rx does, which is not something we want to do. The second thing is that the observable provider has an extended role compared to iQuery provider. Let's actually explain this. So iQuery provider and LINQ to SQL, or LINQ to iQueryable, doesn't really have any visible role. You never have to touch that thing yourself as a user. However, in Rx, we actually have query operators that live on the provider. Now, why do we do that? So here's an example. Say that you do something like, let me see, you do a bidding service on different services online like eBay and some other things, and you want to create some aggregate of all the data with bits on product coming to you, so that you can sort of select the things that you're interested in and start buying stuff. So the thing you want to do is you have 2 observable sequences from 2 bidding providers, and you want to merge them together. So you say left sequence dot merge right sequence. The way that would be implemented in things like LINQ to SQL with a concat operator, which looks pretty much the same. It's an iQueryable with a concat in the middle. The way it would work in iQueryable would be as follows. Left source dot concat right source. Here's the dialog that LINQ does with those sources. Dear left source, do you know how to concatenate right source to you? And that source gets to say, yes, I know, or no, I don't. Now, if you have 2 bidding services, hey, eBay, do you know how to concatenate your bids with that other service, which, by the way, steals lots of money from you because they're very competitive? Then eBay could say, yes, I do know how to do that. I will basically do it by ignoring the other ones, but I won't tell you. So there is no third party to sort of concatenate those results together or merge them together. Basically, the order in which you write things determines the handshake. It's the left source gets to pick. That doesn't make sense in the observable world quite often, because sometimes, it doesn't make sense to have something that streams results and then ask that guy, do you know how to merge the results from something else in there? Typically, you want to have some broker, some intermediary, some third party that knows how to join those things together. And so we have operators on the provider that actually allows you to do that. So you can say, here's a neutral provider for bidding services, dot concat or dot merge of eBay together with all the other ones. And all the other ones are treated on the same level. There are no ones that get the benefit in getting a method call to decide how things execute. So that's actually the extended role of query providers that we have in observables. Little demo, basically to show that link to those kind of things make sense. So let's do link to WMI events. So here I have WMI, Windows Management Instrumentation. I'm looking at the event part of it. And I want to write a query that basically tells me whenever notepad.exe has been started on my machine. So the way I do that is by first creating a observable, because it's queryable observable, of process start trace. And process start trace is just an object that has a process ID of type uint, and it has a process name of type string. It has some, name that's associated with WMI. This is the same like a table on, a link to SQL context, and then you have column, attributes. You could have a column attribute here. We don't need it in WMI, but it's the same kind of mapping mechanism. Now that I have that data source, which is basically an IC observable of, process start trace, which I also give a logger so that we can basically see the code being generated, in this case a WQL query, I can start writing queries. I can do things like, dot, and you see all the, observable queries become available here, which is pretty nice. In fact, this is one of those things that's also a pretty stupid data source. It can only do a where, it can do some time-based operations, not that much. I would benefit here from implementing the state machine approach as well. Also left as an exercise. In fact, the sample ships with an implementation of the query pattern as well. So if you don't want to go for the interface, you can actually have compile time checking as well. But so I have something like where proc.processName equals notepad, select the process name and the process ID. That's all pretty good. Now, one thing I can say, just like you can say in, say for example, link to SQL, you can do as enumerable and then start writing query expressions that execute locally. So you can basically draw a line between what happens remotely, what happens locally. And in this case, the thing I want to do locally is timestamping. That's basically, given an iObservable of t, create an iObservable of timestamped of t. And timestamped of t is an object that contains a t and a datetime offset. So Rx has an operator to basically stamp time on every event that happens in the system. It's a pretty simple operator. It's just a select with some datetime.now associated with it. But that thing, I couldn't move up here. I could try to do timestamp here, but WMI doesn't know how to timestamp things. So I couldn't translate it into WQL statements. I need to do that after the asObservable. But you see that you can mix and match things locally and remotely. If I execute this thing and I press F5, what's happening is this. We did res.subscribe, right? Res.subscribe compiled that entire query expression using some expression tree visitors into a WQL statement that's now sent to the WMI engine, which is just some component in the Windows operating system. So that thing got this magic string and knows how to execute it. And that happened upon doing subscribe. That's exactly the same as with LINQ, classic LINQ, where upon doing a for each over a data source, the code gets generated. It's not until you do a for each over a link to SQL query that the T-SQL gets generated, unless you did a .compile and all of that stuff. But so it's exactly the same thing. It's lazy. Means that query is not going until you subscribe to it. So I've done a subscription in, that's non-blocking. That's just, it has happened. I passed in what to do when an event arrives. So I will simply take T, which will be a time-stamped process, process start trace. I will just print that to the console. I can also pass in some other lambdas that indicate completion, exceptions. I can pass in those lambdas as well. Now my main thread here will actually start creating processes. So when I press F5 here, I basically have something that just starts notepad instances. There we go. That's happening on the background thread. But here you see, oh, while the main thread is actually creating notepad instances, WMI has seen, oh, there is a new notepad.exe that was started, and you see we get a callback. The subscribe, the Lambda that's sitting there, gets called saying, hey, a process was created. So now I can put that onto the screen. If I do right-click Show External Code, you will actually see we're in the middle of the system.reactiveDRX data stack. Here we're doing some timestamping operations, and ultimately, you will see at the bottom of the stack, you see system.management.dll sync for event query. That's actually where the system.management wrapper of the .NET framework talks to WMI and sort of gets the events out of a p-invoke layer. So the event simply bubbles to me as something of type T, which is a timestamped anonymous type in this case. So when you actually, let's actually get rid of the breakpoint and do F5, there we go. Processes are being created, and for every process that was created, and it takes a few, maybe up to a second for WMI to forward that event, and you can actually do some settings around that, you see that, some processes were started and it happened at a particular time. The time is a little out of whack because I'm still in some other time zone here, but you see, stuff is just, flowing through the pipeline. So I took a query expression, turned the expression tree into WQL, which you are seeing because I've enabled logging, and now it's WMI doing everything to basically get notepad.exe and the process IDs. The stuff behind it, the add part, is part of our timestamp of T class, which is done by local execution inside reactive extensions. That's the thing that actually stamps time on events. So there we go. That's actually using LINQ over another kind of data source. So to go a little further with regards to where Rx is, in my previous talk I talked a little bit about the async CTP. Just a quick recap in case you weren't there. So the idea of the async CTP is that you can write async methods, you can await operations inside, which means that all the code beyond the await gets executed when the awaited object completes. So in this case, computing n.length will only execute when the task of string is completed. So all that code gets lifted into the continue with call, sort of. So that's what's going on here. Now, the await keyword can be overloaded. You can actually take await and implement your own awaiters. And that's what you can do by implementing getAwaiter, something called onCompleted, something called hasCompleted, which is a Boolean property or method. And that's basically what you have to do. And then the await keyword just works against anything that implements the pattern, just like for each works against anything that has a get enumerator with move next and current. And so awaiting a task exists that will actually ship as part of the async CTP. You can await a task, which uses extension methods called getAwaiter and all of that stuff. And the result of doing that is a single value. If you await a task of T, the thing that comes out is the T that was computed. Or an exception might be thrown if something terribly went wrong. Now, can you also await an observable? Can you await an observable sequence? The answer is yes, but there are some choices to be made, because an observable sequence is, well, it's a sequence. It doesn't just contain a single value. Like, can you await mouse moves? That's an iObservable of point. It's an infinite one, even. Like, whenever you move the mouse, you get a new point. Like, how do you await that thing? We have to make a choice there. So the thing we do is, when you await an observable, we give you back the last result. Last is the closest to single to us. Like, last is the thing that happens before completion. For task of T, it's the same. When the task completes, the previous value, which happens to be the single value, is the result of awaiting. So when you await an observable sequence, you get the last result back. However, you can also await for the first result, because we have, of course, a take1 method. You can do await sequence.take1. Well, the take1 sequence completes when the first element of the other sequence comes in. So you can always await the first element. You can also await all the elements. Say that you want to get the whole thing back. You can await an observable by doing .toList. That's an important thing here. The way that toList works in Rx is not by returning a list, but it returns an iObservable of list. Let's actually show that somewhere. I can show that here. Result.toList. As you can see, result.toList returns an iObservable of iList, not just an iList. Because returning an iList would be blocking. It would have to wait till the whole thing is finished. That doesn't make sense in the asynchronous world. So we still return an iObservable that contains the iList as a single value. So if you want to await all the results, you can do res.toList, and then you can await it. I think we have getAwaiter sitting here. If this Visual Studio instance actually had support for the await language keyword, I could actually just do await on the toList. But the compiler, when you write await on this thing, it basically tries to call into getAwaiter, and on the object it gets back, it calls a couple of methods to do the await operation. It's just syntactic sugar again, and actually the language spec is just like 2 pages. Just saying like, await x turns into x.getAwaiter with all of that fancy stuff around it. That's basically how the feature is documented. Behind the scenes, there's a little bit more work, but it happens. Now, can we do some other stuff as well? So awaiting an observable sequence is useful in the sense that now you can use imperative-style code to basically get the last value of a sequence and react to that. That might make sense in certain cases. But the thing is, iObservable sequences are really push-based sequences of getting values submitted to you. Maybe we also want to have an asynchronous way of doing pull-based data access. And that's a very rough thinking and experiment that we have floating around somewhere. Could we do something like this, where we say, what if we have an async enumerable? And by the way, we're not completely serious about that, but it's just an interesting thought exercise. Say that you have an async enumerable that returns an async enumerator from getEnumerator, and the only difference is that moveNext doesn't return a Boolean, which is why actually using for each can be blocking, because moveNext can refuse to come back to you saying yes or no. So what if we return that thing as a task of Boolean? So that whenever you do moveNext, you have a task that you can await till the result becomes available. Now we can do some kind of asynchronous for each by means of that. And in fact, in Rx we shipped operators for this interface just to experiment a little with that. Now, if you think you like this a lot, then talk to us, and we might actually continue shipping that with Rx. But so that's a rough idea there. So we have all the query operators actually sitting in there. So that's the basic idea. So let's actually just show the await support for observable collections or observable sequences. Let's be clear here. Observable sequences are iObservable of t. Doesn't have to do anything with observable collection in WPF or Silverlight. Not at all anything. It's just, observable sequence is iObservable of t. Observable collection happens to be some UI-related thing. Sometimes I say observable collection. In that case, substitute it with observable sequence. So let's create a new project. Just a little console app that will do. And let's take a look at some observable stuff. Let's add a reference to the latest version of Rx that will be online later today or tomorrow. So I will just add system.reactive. In previous versions, we had some different assemblies. We also had an assembly called system.coreax. We just got away with that. And now we simply have just one assembly called system.reactive. We have a couple of other assemblies for query expression kind of manipulations. So now that I have system.reactive, I can do something like observable dot, say for example I want to create a timer, time span from seconds 0, one that starts immediately and repeats every 1 second. So what I have now is a collection, not a collection, a sequence, forgive me again, an iObservable of int64s, an iObservable of longs. That will be just monotonically increasing. The first time the timer ticks, it will produce a 0. The second time it will produce a 1, then a 2, then a 3, then a 4, and so on. So basically, whoops, I almost fell over here. I can subscribe to this thing. I can say x.subscribe, x goes to console write line x, something like this, right? And I can execute this code that will basically give me a timer on the screen. Well, not that quickly because it's asynchronous. The subscribe method immediately returns. There are some background threads going on. So, because my application already quit, the thing stops doing stuff, right? So let's put in just console.readline here to keep my main thread alive. With a UI program, you wouldn't have to do that. But now you get an iObservable of long to which we have subscribed, and whenever a value comes through, we just put it onto the screen. So that's the thing you're actually seeing happening here. Now let's say on that timer I want to get the current time. I could do something like from x in observable.timer, select datetime.now. At this point, I have an observable of datetimes that just gives me the current time. If I hover over x, you will actually see this is now a sequence of datetimes, and every time I receive one, I will print it to the screen. So now we have a little clock here. It's just a sequence of timestamps that's coming out. Now let's say I want to stop this thing after 10 ticks, or let's say 5 ticks. I could say .take5, right? So now if I execute this thing, you will see after 5 things it stops. So you can just compose those queries endlessly. Now we have a sequence that actually will stop at some point. Well, that's the thing I can actually await. So this sequence, I could say await x's, var x equals await x's, or var last equals await x's. And this is interesting. Why doesn't this work? Okay. My async method needs to be, tagged as async, and I need to add a reference to the async CTP helper DLL, which ultimately will be integrated into system.core or mscorelib or something. But so for the time being, you need to add a reference to the async CTP library, which contains compiler helpers that actually are used in the translation for the await keyword. But ultimately, this await just binds, as you can see, to an iObservable. Await is not tied to task of t. You can await everything that implements the awaiter pattern. And so when I do that, this awaiting, I can do console.writeLine of the last value, and that would actually give me the last time tick coming out of the system here. It's a little unfortunate I'm doing this in the main thread, and that will actually quit prematurely because I hit the await here, which says I'm immediately done, and my continuation doesn't have any chance of executing because the main thread already quit. So ideally, I would have to spawn some different thread. Let's actually try that. Typically, you do this in a UI program or something, or, well, why not? Let's just create a UI. Let's just do that. Let's do it in a UI. Var form equals new form, like this, not format exception. Form, please. Form, please. Speech recognition in Visual Studio doesn't work yet. Next version. Application.run form. And now let's just do all of that stuff. I just want my application not to quit prematurely, so I'm just pumping some UI. That's the easiest way for me to do that. Form.load plus equals o, e. I don't care about those things. And let's just lift all of that code into the UI. And so I'm doing that now on the UI thread, but I'm not really getting the UI thread in a stuck state. Oh, I need to make this thing an async lambda now, because I'm using async, or the await feature can only happen in an async block, so I need to decorate that. Now when I do that, well, you might say this thing is going to hang the UI till the last value comes around. The answer is no, because I'm using await. Await means it happens asynchronously, so we basically get a UI message posted back when the value comes into existence. So I'm not really hanging the UI by doing this. So when I execute this, my UI is still responsive, I can do stuff, and thereafter, the 5 seconds, the last value of the observable was produced, the await succeeded, and the rest of that code started executing magically. So the console write line actually happened. I should even be able to actually put that onto the UI here without causing a cross-thread violation. So I could do form.title equals last.toString. Well, that's fine too. Oops, it's not title. Is it text? Text. So I will just update the UI, from that background operation after the 5 seconds complete. So you see the title was actually changed, and I didn't cause a cross-thread violation because await is kind of nice to me. So that's what's going on. Let's get to the next part. Some random thoughts about where execution happens. I showed you the 3 dimensions of LINQ before. What do you want to do? Pull-based or push-based? Do you want to use expression trees or IL code, which allows us to do link to SQL, link to WMI, link to NASDAQ, those kind of things? But where do things happen when you do things asynchronously? Like there needs to be some place that generates the work or generates, the values. And that's where our notion in Rx of an iScheduler actually comes into existence. iScheduler is an abstraction we put in place so that you can basically tell where to generate values. Let me actually show you this in practice before going anything further. Say that in Rx you do something like observable.timer. Well, where do those timer messages get created? Like, who's actually pumping values out without blocking the main thread? Well, the answer is for observable.timer, the default is using the thread pool. However, for all the things that introduce work in the system, that need to introduce messages in the system, in Rx you can parameterize those guys using what's called a scheduler. So here you see an optional parameter. It's not encoded as an optional parameter. We simply use overloads here. But you can do a system reactive concurrency.iScheduler, where you can say, and I want those guys to be created on the current thread immediately, which means it's blocking, on a separate thread, a dedicated thread to generate messages. That sounds kind of fancy. I can do it on the task pool. I can do it on the thread pool. I can even use WPF dispatchers and WinForms dispatchers as well. Then I need to include a different namespace to actually get access to those schedulers. But so that's the notion of a scheduler, where things execute in the system. So that's the big idea here. Where do schedulers come from, by the way? Let's actually create a little clock here, like this. Let's say I want to do access.subscribe, x goes to, and let's actually update the text of the form without using a wait, so you know there are no rescue nets being added for me. And let's do x.toString, like this. So I'm just updating the title of the UI every time the timer ticks. Now, where are those messages being generated? Those messages are generated by default on the thread pool, in this case. The default is something I always need to look up in my matrix memory here. But the default for timer is the thread pool. So ultimately, this piece of code here that executes under the subscribe whenever the messages are received happens on the thread pool. On the thread pool, I should not update the UI, as WinForms is telling me. Don't do this. So we said at some point, well, what do we need to do in Rx to make this really work? Do we want to always handshake with a synchronization context? Do we always pump UI messages? What do we do? And so we said in Rx, well, we can just compose where things happen into the query. I can say, instead of subscribing on Access directly, I can say, dear Access, please get observed on a particular scheduler. That's sort of tossing it over the wall to execute somewhere else. And so I'm going to say access.observeOn, and here I can now pass in a scheduler. We also have overloads that take in UI constructs like a form. And in fact, in order to do that, I need to add a reference to System Reactive Windows Forms, which contains that functionality to synchronize with UI threads. We've separated that out in a separate library to avoid having some dependencies on System Windows Forms in the core of Rx. But so now, what's really happening, this uses a scheduler behind the scenes. Whenever a message is received on Access, that message gets queued into a queue of a scheduler that runs somewhere else, in this case on the UI thread. If I execute this, you see that I don't get an exception anymore, and my UI is actually pumping values in the title bar. And that's now not causing thread exceptions because the observer actually tossed it over to the UI queue. And that's the notion of an iScheduler that basically determines where things execute in the system. And so we've been noodling around actually with creating cloud schedulers as well, so that you can do something like observable.timer on Windows Azure. And then that thing is basically running the clock and sending out messages. Like now we can sort of take parts of a query and run them somewhere else. That's why we call the cloud programmability team to do that kind of crazy stuff. So let's actually take a look at this abstraction. Don't care too much about the interface, but the idea of the interface is we have 3 schedule methods, one with no time, which means try to do it as soon as you can, one that says with some relative time from now, like you can say schedule something in 5 seconds, that's relative time. You can say schedule something on Christmas Day next year, that's with an absolute time. So you can actually do that. Schedulers are used to introduce or reduce concurrency in the system. Like for example, if we go from enumerable to observable, we need to introduce concurrency because, well, if we enumerate an enumerable, we can get stuck. So the thing we actually do is we use a scheduler to basically execute the for each. That happens on a background thread, for example, and then pump out messages in the observable. So that's a place where we need schedulers. So that's sort of all I want to say about this. This is the thing I showed in Visual Studio, the fact that if we put observe on there, things look nice. And so that's basically a way to control where those messages are being sent out. So that's the rationale originally for having schedulers, but they've paid off much more. So some random thoughts on this. Maybe you could take schedulers one step further. If you look at LINQ to SQL today, in LINQ to SQL, when you look at a Northwind data context, for example, it has two things associated with it. And whenever there are two things that are orthogonal, bundled together in the same abstraction, I sort of get scared. So in this case, Northwind data context, which is just a SQL context generated, knows where to execute things because it knows about the connection string that you can set to a settings file. It also knows the whole schema. It knows about the product and it knows about the category and the supplier and all of that stuff. So it's really two things bundled together. But that where part, I don't quite like. Why does the entry point to my LINQ to SQL need to know where things will be executed eventually? Isn't that something I want to say later? Please, by the way, execute this query over there. So there we could use a scheduler. We could do something like, for example, Northwind data context no longer knows about the connection string, but now I can say something like result.remoteOn, a SQL scheduler passing in the data source connection. Now I could also do composition on schedulers. I could say result.remoteOn, new SQL scheduler server1 .or new SQL scheduler 2. Then I have a LINQ to SQL query that can be distributed over multiple machines. So, of course, somebody will have to implement that whole remote-on facility. But like by detangling it from actually the Northwind data context or the data context base type, we might actually gain much more expressiveness in the system. So that's something likely not for the classic LINQ providers, but there might be something in a cloud context that makes a lot of sense. Some other things we've done, I'm going to basically bypass that because I have something very nice near the end, is we've actually looked at remoting entire expression trees from one machine to the other. That's something I actually have running on the machine here. If you're interested, please come to me. I can actually demonstrate that. The basic idea is this. Today, just think about what happens when you take a LINQ expression and try to execute it, for example, in a relational database engine, whatever it is, SQL, Oracle, whatever. What happens is you have your piece of C# code. The C# code gets given to the compiler. The compiler creates an abstract syntax tree out of your source code. Then it creates an expression tree at runtime for exactly the same source code. It gives that tree to LINQ to SQL. LINQ to SQL says, I'm going to flatten it down into a T-SQL string. Now it's a little string which I can send over the wire. Then SQL says, oh, thank you for giving me this little string that contains T-SQL. I'm going to parse it, make an expression tree out of that, make some query plan out of it, which typically also is tree-shaped, and then I start executing it. Why did we go to the string in the first place? Why didn't we just say, dear SQL, here's an expression tree represented as data? There'll be some serialization protocol that you need, but the thing is, why do you want to do all of that round tripping? Sort of, first go to a string and then say, hey, now you get a string here, you need to do parsing again. Like, if you could just send it over, it would be much nicer. So we actually do have remoting for query expressions working. Now, I want to skip this one because I got one last thing on the menu, like sort of the dessert, which is linked to the totally unexpected, and I like this a lot. So what I have here is something called Solver Foundation. You can actually find that product online. It's basically a constraint solver framework that allows you to make decisions given a set of constraints. In this case, this is some kind of ugly language that they do have in Solver Foundation. And the problem that I basically give here to Solver Foundation is to decide how much barrels of oil to get from Saudi Arabia and Venezuela in order to meet some criteria to get my production plant going. So I'm telling to Solver Foundation here, first of all, that I want to, over here, minimize the cost. No matter how many barrels you choose from Saudi Arabia and Venezuela, I know that every barrel in Saudi Arabia is $20 and in Venezuela is $15. So I want to minimize the total cost. You decide how many to get in which location, but I want to minimize the cost, so I have to say this piece of info. It's the first row of the table sort of encoded. Then I have some constraints. Constraints based on the refinements. For my production plant, I need, for example, at least 2,000 barrels of, let's see, gasoline. But gasoline in Saudi Arabia, for every barrel you get in Saudi Arabia, only 30% can be used as gasoline. But if I buy oil in Venezuela, 40% can be used as gasoline. So I need to tell Solver Foundation, well, if you take that many units in Saudi and that many in Venezuela, then it needs to add up to at least 2,000 barrels usable for gasoline. And then the same with things like jet fuel, lubricant, and waste. So I basically encode this whole thing in there. And then I also say, like in Saudi Arabia, I can order at most 9,000 barrels for some reason, at most 6,000 in Venezuela. And I don't want to have negative barrels because I don't want to send oil to somebody. That would totally not make sense. So I just encode that whole thing. But actually, holy smokes, what does this query language look like? This is too complicated for me. I don't understand this language with square brackets and arrows and all of that. So can't we just do this whole thing using LINQ? And the answer is yes, because, well, constraints are like filters. Decisions, which really are about minimizing or maximizing something, are like order bys. Order all the hypothetical results of this particular query and get me the top one or the bottom one, depending on whether you want to minimize or maximize. So we can take this whole thing and basically do something like this. From M in, create a model where Venezuela and Saudi Arabia are both doubles, for which you will give me values. And those are the constraints to actually deal with. Now notice one thing here. That domain that you have sitting there, context.createModel, is even not enumerable from a mathematical point of view. This is definitely not linked to enumerable. Because if it would be linked to enumerable, in that case, what would we have to do? We would have to enumerate all the doubles times all the doubles. Well, you can't enumerate doubles. You get stuck immediately. You do 0.1, 0.0.1, 0.0.0.1, and like you just go down the drain. You don't cover the entire surface. Like it's a fundamental mathematical property. So in this case, nothing is enumerating. We are basically transcoding that whole expression tree into something that gives rise to mathematical expressions in Solver Foundation that then does, the high school mathematics to solve the equations. And, lots of other crazy stuff that I don't understand. But I don't care about that because I can write the link provider to it. So it's pretty nice. So it's a non-persistible, model. You can't enumerate the whole thing. And in order to get the result out, well, you don't do a for each because there's only one result. I just have a method called solve that gives you the answer or throws an exception if it's not, it cannot be met, it's unsatisfiable. So just one extension to that is we could totally embed that link to Solver Foundation part into reactive extensions. We could combine some price stickers, price monitors that basically say the price has gone up, the price has gone down, into a bigger query that solves the equations every time something changes. And at the bottom you could say .subscribe send mail to the manager, saying that today you want to buy 5 barrels more in Saudi and 5 less in Venezuela because the price has changed. So now that whole thing sort of starts sticking live. Like you just subscribe to that and every time something changes, Solver Foundation says I'm going to solve it and then pump out a result. So this looks pretty interesting, actually, because now you have all your logic for decisions in one single LINQ query expression. Now, I will show you some other Solver Foundation kind of thing. Actually, I will not use Solver Foundation. I will just use C3 to finish up my talk here. C3 is a theorem solver, or constraint solver better, from Microsoft Research. You can actually find it on MSR. And it's pretty similar to Solver Foundation. It does different things for certain domains, but in principle it has very close relationship. So what I have here is linked to Solver Foundation, where I say, for example, for this first one, I'm saying I want to create some theory that consists of 3 decisions, 3 int values, and I happen to know that x1 minus x2 needs to be larger than 1. x1 minus x2 needs to be lower or equal to 3, and x1 needs to be 2 times x3 plus x2. So I'm just giving that whole equation, and now I'm asking Solver Foundation, do you know anything that satisfies those constraints? And so I do a solve on that thing, and it comes back with an anonymous type that contains, or well, actually with a named symbols type that contains the results. So that's fine. Solver Foundation told me, C3 told me that if x1 is 0, x2 is minus 2, and x3 is 1, those constraints actually hold. So I've just expressed them using a LINQ query. The next sample I have here, and with that I want to conclude, is, Well, now you can also write link to Sudokus. Like, pretty simple to do. You basically tell all the constraints of the entire matrix to Z3, basically saying that every value needs to be between 1 and 9. You know, all the things in the cells need to be distinct. The ones that I know are the ones that I have here. First row, third column is 2, first row, sixth column is 1, and so on. You just give all of that stuff to Z3, and Z3 can start crunching on it for just a second, and then we get the result on the screen. So there we go, F5, whoops, there we go. That's the solution of the Sudoku. Now expressed using a LINQ query expression. The only thing I did was just, I don't understand how Z3 works. It's like dark magic to me. I just know what strings to give it in order to execute something. That's called actually SMT. SMT-lib is the format you send to Z3. In fact, LINQ to Z3 actually talks to the pinvoke library as opposed to creating a string first, because I'm fundamentally opposed to creating a string if they are going to parse it anyway. So I just talk to their pinvoke libraries. But so here you see, for example, that the generated code is that, you know, every cell on the same row needs to be distinct. For example, all those constraints are being sent to Z3. Everything needs to be between 1 and 9. I'm also sending all those constraints to Z3. It knows how to solve it. Some other constraints over here, you know, makes up for a nice wallpaper, actually. So I'm giving it all of that, as well as, you know, all the values that I do know. That's somewhere sitting at the bottom here. The values that I do know are also communicated. Cell 1.3 is 2, 1.6 is 1, and so on. And ultimately, Z3 comes with some solution. And we also have samples for can-can puzzles, like all the puzzles you can find in those cheap magazines. You actually have readily solved over here. And it's much more fun to write, you know, a link provider for those puzzles than trying to solve the puzzles themselves. So that's what I did. So with that, actually, futuristic perspective on LINQ, sort of to tie back to where we started. Next 5 years, you know, there is a team called Cloud Programmability. It's led by Eric Meyer, who's my boss. He's one of the inventors of LINQ. And we believe a lot in, you know, taking it to the next stage. So what we've seen is that standard query operators with Rx, we got quite a lot more that are time-based. I've just shown you, you know, observable timer, but there are a lot more in there that are very useful for event processing systems. So event processing you can do using LINQ as well now. We're looking at, you know, reaching more domains at the bottom. I have, for example, a production quality link to Active Directory sitting somewhere that we might ship at some point. So lots more domains at the bottom there. You might also see more toolkits, because I don't expect people to start writing state machines of types, like I showed somewhere at the beginning of the talk. That's something you can totally generate from some grammar specification, for example. So it might make sense to have toolkits that do that kind of stuff. We integrate with things like async. Schedulers are very promising as a way to abstract where things happen. Serialization of expression trees is yet another thing that I sort of touched upon very briefly. So with that, I actually think I'm done. Thank you for your attention. If you want to get more questions out of me or answers out of me corresponding to certain questions, please come to me, ask me anything you want to know. And with that, you know, thanks for your attention.